Hey everyone, welcome to Open Space for June 17th, 2019, the penultimate episode before we go on to our summer hiatus of live events. Not all the stuff. In fact, just the weekly space hangout, astronomy cast, and open space. Those are the live events. And of course, the problem is that every week I have to scramble to make sure that I'm close to high speed internet. And so over the summer, I'm able to slow down and work on some of the deeper projects. Think, that kind of thing. So, so we'll do the open space tonight, and then we'll do one final episode next week, and then we'll go on hiatus. But I'll still be here, and there'll probably be all kinds of other interesting projects. Again, I want to freak you out and think that this is all going to come to an end. All right, so of course, the purpose of open space here is to give you folks a chance to hit me with your questions directly, live, in person, and I will respond and answer as best I can. Especially stuff that's new, news, stuff that's in current events. I'd love to hear it. So, let's see, what else is happening that's interesting? My telescope is in a different configuration, and that's because I was out looking at Jupiter 2 nights ago. It's so cool right now. Jupiter is really close, within, it's a spot they call opposition, and it's essentially the closest point in its orbit to Earth. And so it is big and bright in the sky. And so if Jupiter is looking really bright, this is why. And it's so bright that you can just use a pair of binoculars and actually see the moons around Jupiter. So I highly recommend it. The telescope is really heavy. Like I can barely carry it up the stairs to be able to go and look at Jupiter. So I'm thinking of following my own advice and getting my hands on a Dobsonian telescope. So, which is sort of the simplest but quickest way to be able to really see the night sky really nicely. It's got like a great big aperture, 8 inches, so you can really see things very magnified. And you just grab it and turn very quickly. I highly recommend it. So for Justin Garver is asking, what do you recommend for a good telescope, and how much will a good telescope cost you? So the first telescope that I recommend that everybody buys is this thing called the Dobsonian telescope. And that's not a manufacturer, that is a style of telescope. And it is named after a guy named John Dobson. And it is the simplest telescope. It is really just a big tube that has a flat mount on it, and you can move it around the sky. And you use like a little finder eyepiece. You can see things in the sky, and boom, you are able to find what you're looking for. Highly recommend it. And then once you have you're getting sick of using your Dobsonian telescope and you still want to do astronomy, then go to the next level and buy something like this, which has a nice mount, and you can do astrophotography and things like that. But always recommend a Dobsonian telescope. Sean Marson says, hey Fraser, can you explain why a rocket launches vertically at first as opposed to a direct 45-degree angle to space? Thanks. Yeah, so, when a rocket launches, rocket has to do really two things. The first thing that it has to do is it has to get out of as much of the atmosphere as possible. And then the second thing that it has to do is it has to start going sideways at 28,000 kilometers per hour. It has to go 7.66 kilometers per second, which is very, very fast in order to be in low Earth orbit. And so when the rocket first launches, you've got a tremendous amount of atmosphere that it has to push its way through. And you want to get up and out through that atmosphere as quickly as possible. And so a rocket will take a trajectory that takes it up first, gets through the bulk of the atmosphere, and then it will start to roll over onto its side and now be going sideways faster and faster and faster until it has reached low Earth orbit. And so that's why they do that. Oh, and Justin Garver's asking, how much would a good telescope cost? So yeah, so if you buy that Dobsonian telescope, they're, you can get them for between $300 and $500. You shouldn't spend more than that amount of money, and that is a really serious good telescope. Don't buy one with a fancy mount. Don't buy one that'll track. Don't buy any of that stuff. Just a good Dobsonian telescope is a really quick way to be able to really get accustomed to the night sky, but have a really good seeing experience. Like, you'll see the bands on Jupiter, and you'll see the Great Red Spot, and you'll see the moons, and you'll see the rings of Saturn, and you'll see the Cassini division, and the moons of Saturn, and you can see the craters on the moon. And it's absolutely the way to go. Teom is asking, what is LIGO seeing these days? I understand it's up and running again, but no news on what it's been seeing. Actually, I posted a video about a month ago about all of the cool new stuff that LIGO is seeing. And the gist is that LIGO is seeing one new gravitational wave event, one new black hole collision or neutron star collision every week, as predicted with the new run. So far, it's just been right on schedule, delivering all kinds of amazing things. And one of the new things that's been discovered is this black hole neutron star collision that's been seen for the first time. So pretty exciting what LIGO is up to. And it's just giving you this glimpse for what the future is going to look like when we get to this time where we have really powerful, really sensitive gravitational wave instruments all the time. And I really love this story. Like the LIGO instrument itself, they won a Nobel Prize for developing LIGO in the first place, because people never thought it was even going to be possible that it would be able to be able to detect gravitational waves. And for the first several years with LIGO, they didn't detect any signals at all, but they learned all of their lessons, and then they improved the instrument. And now we're at this point where they're coming up with really clever ways to make the mirrors more sensitive, to make the lasers more powerful, and they're able to, each time they double the accuracy of LIGO, it allows them to push out into a larger sphere of the universe to be able to detect. And they're learning all these lessons for what the next generation of gravitational wave telescopes are going to look like. And each new gravitational wave telescope that comes online increases and improves the overall capability of the entire network. And they can be anywhere on Earth, right? They don't have to be looking at the sky in a certain spot. Just their existence brings value for the system entirely. People are reminding me that we are going to have Corey Gray from LIGO, who is going to be on the Weekly Space Hangout on Wednesday. So if you want to hear us interview somebody from the LIGO project, we're going to be doing that on Wednesday on the Weekly Space Hangout, which is at 5 o'clock. So in 2 days, at this exact same time. So you should definitely come and check us out. Josh M asks, could humans ever visit Jupiter's moons, or would the radiation belts be too strong? Yeah, the radiation belts around Jupiter are awful. They are really, really bad. So Jupiter has a magnetosphere like the Earth has a magnetosphere. And in the case of Jupiter, the magnetosphere is caused by the rotation of its core, which is magnetic hydrogen, or metallic hydrogen. And so this rotating metallic hydrogen forms this dynamo, like the Earth's core forms a dynamo, and it creates this gigantic magnetosphere. And it's estimated that the magnetosphere is 50 to 100 times the radius of Jupiter, so really big. And all of the big icy moons that are interesting in Jupiter orbit within this magnetosphere. And so if you went to try and stand on the surface of Jupiter, you would receive a lethal dose of radiation in a very short period of time, just a couple of hours. It is, I think, 20,000 times stronger than Earth's magnetosphere. I just looked into this, but I don't remember the exact numbers. Anyway, it's way bigger and it's way stronger. And so it is just an awful, awful place. And in fact, NASA, when they're sending space missions into Jupiter, they have to consider the strength of the magnetosphere on the electronics of the robots that they're sending. Like, it's not even they're worried about humans, they're worried about just robots, right? And the terrible radiation load. So Juno, for example, is designed to come quickly into the orbit of Jupiter, quickly do a flyby and then zip back out again and sort of minimize the amount of radiation that it experiences. And the same thing is going to happen with the Europa Clipper. It's not going to be orbiting Europa because that's just too much of a radiation load for a poor spacecraft. It's going to zip in, take some pictures of Europa, and zip back out again and then wait for it to come back in again and try to minimize that damage. So it's a very, very cool way to approach this. So yeah, no, Jupiter is the worst. Denticator says, what do you think about the Lunar Gateway? So I've done an episode on the Lunar Gateway. It was about a year and a half ago, I think. And back then, the original plan was build the gateway, and then once the gateway is complete, then you would use that as a stepping off point for sending humans down to the surface of the moon. And they were thinking like maybe by 2028. So now the plan now is to send humans to the moon by 2024, knocking 4 years off of the timeline. And so they've had to make some changes. And so the changes is that they're still going to build the Lunar Gateway, but now they're going to build just one module, the power module. And they're going to use that as a sort of a stepping stone down to the surface of the moon. So the astronauts will launch off of Earth in an SLS, in their Orion capsule. They'll fly to the Lunar Gateway, which is just going to be one module, one space station flying in a cislunar orbit. And then they're going to leave the gateway and they're going to fly down to the surface of the moon and then come back up to the gateway and then come back to Earth. And so that makes sense, right? And I think that, in fact, if I was, building just this one module as a way to test whether it even makes sense to be able to get down to the moon, I think that's fine, right? By all means, if the plan is to put humans on the moon, put humans on the moon. And then if you like having humans on the moon, then by all means, expand the capability of the Lunar Gateway. Add all these different modules, have people spend longer periods of time out in deep space. And then use the Lunar Gateway to go to other places, right? To go to nearby asteroids, to eventually fly to Mars. So I think, the Lunar Gateway is probably the next step. Like, let's have a platform like we learned with the space station, but now in a much farther orbit where we have to learn how to live in deep space with all of the radiation and all the other hazards that are out there and the longer periods of time to get there and the difficulties in communicating. Like, there's a lot of new challenges to get out there. And so I think that makes a ton of sense. If I, had the whole budget of NASA to work with, is that what I would do? Probably not. Right? I would have other priorities personally, but I think it's fine. And I think when you're working with the constraints of you've got all of the existing congressional budgets and all of the senators and all of the priorities and all of the contractors that you're working with and all of the employees and all the stuff that's going on, the Lunar Gateway is a nice next step. It beats just going around and around on the International Space Station. Brad McGashett says, are there any viable proposed methods for drilling through Europa's miles of thick ice, such as induction heating or something else? Thanks. Another episode that we did. This one's maybe a year and a half ago, an episode all about a mission that's been planned to drill underneath the ice on Europa. And the method is very cool. You sort of make a bullet, like a big long torpedo, and you have a nuclear RTG reactor in the probe, and then it melts down through the ice from its front, and then it has pumps that can push the water through the probe and out to the very back, where it freezes again behind it as it goes back down. And so you slowly sink down through the ice, and depending on the thickness of the probe, it can take 6 months, or it might take 2 years to get all the way down through the ice on Europa to get to the bottom where you can actually access the liquid ocean underneath. But like I said, I did a whole episode on this, so just search on my channel for like Europa. And oh, there you go. Paranor just put it into the chat, so you can check that out. Josh M., do you think that the ISS will have a true successor? So will the International Space Station have a true successor? Yes, I think that we are going to want to have some kind of space station orbiting the Earth at all times. It makes sense, right? You've got the International Space Station, even though it is incredibly expensive, the most complicated machine that humanity has ever built. It's cost, whatever, $150 billion. It's pretty handy to have a space station up there. It's an international collaboration. I really like international collaborations. It's a place that it's this platform that you can do experiments on. And in fact, the Chinese are planning to build their own space station shortly and launch it. And they've opened it up to international partners to put experiments on board the International Space Station. On the Chinese International Space Station, I don't think the Americans are invited, but then the Americans didn't invite the Chinese, so it makes sense. And they've gotten, I think, 15, 20 different countries to have proposed experiments that they're going to run. So I think it makes sense. And from this point all the way forward, we'll probably always have some kind of low Earth orbiting space station. And whenever the International Space Station comes down, then we'll see something else go up. And it might be like an inflatable Bigelow habitat or some kind of, I don't know, tourism habitat that also has some room for NASA and other space agencies to pay for doing some science on them as well. But I think get used to having some kind of space station forever. Nikki says, love the show, and then he plans to send a probe to Uranus or Neptune. I mean, it's funny. So we've done an episode on that as well, about 2 years ago, about plans that we need to go back to Uranus and Neptune. And I detailed the plans for a mission that have been proposed. There's been a few tiny updates on that. So back then, the plan was like a really big mission on either a space launch system or a Falcon Heavy, something that would go to either Uranus or Neptune or both and send orbiters and send landers and be able to actually detect the information about these planets and their moons. And then someone has proposed a much more slimmed down mission that might launch on a Falcon Heavy but go really quickly and spend some time analyzing Triton, which is this really fascinating moon of Neptune that goes in the wrong direction from the rest of the moons around Neptune, and the rest in general, the direction that moons go, it seems to have geysers on it. So it's a very fascinating, very interesting target for further exploration. And all we've got are just these really quick, simple photographs that were taken by the Voyager 2 spacecraft as it went by in 1989. And we need to go back. So I really hope that someone, if I had to make my priorities, right, I like a mission to Titan would come next. Then I would like to see probably a mission back to Venus and maybe some new technologies to try and like balloons or things like that, and then probably a mission to Uranus or Neptune. So, and there you go. And Lawrence Bell says Venus is a terrible, terrible idea. Is there any reason to still believe in a manned Venus mission? I don't think that we're going to see a crewed mission to Venus in any near term, right? There's no point to send humans to Venus. But Venus itself is an absolutely fascinating world when you think about it. It is the same size and mass as the Earth. Essentially, it's a little less, but still, like if you could remove its terrible, terrible atmosphere, it's the only place that you could walk around on and kind of feel like you're on Earth. It's amazing. And yet something went really wrong on Venus. Something happened with its geology that we just don't understand. And so it's this fascinating world that we need to understand better. I'm more interested in Venus now than almost any other place in the solar system. Not because I want to fix it, right? Like it's awful, but just because I want to understand. I want to understand the history. I want to know how worlds like Venus go bad. And so we need to go back. And now there's some really interesting technology that could handle some of the higher heat. Like back in the day, the Soviets sent all of their Venera spacecraft down, and they all just died horrible deaths in the hot temperatures. But now NASA has developed some pretty cool technology that can withstand really high heat and still do work. So it might very well be that we could send a rover down to the surface of Venus that could plug around for months exploring that awful place. And I would love to know the answers. So, Zephan, how is Project Starshot coming along? Any news about it? No news. I haven't heard any news. The one tiny little piece of news was about 3 months ago, uh, and I forget the name of the organization now, but there was a university did an experiment where they flew a tiny little chip, a little satellite. Their question was like, what's the smallest possible satellite that we can launch to space? And so they put it on a balloon and put it really high up at altitude, and they were able to communicate with it, and it was able to function, and but like a tiny little chip. And so I think there's going to be more precursor technologies to move on to get to the point that we do Project Starshot. That said, the Planetary Society is going to be launching their Light Sail 2 spacecraft in the next couple of months on a Falcon Heavy, and that's going to be like, a serious attempt to raise the orbit of a spacecraft using only light power, only the power of sunlight. And if that works, then it demonstrates that solar sails, that light sails, are a viable way of getting around the solar system. And so then you can imagine a next version where it's a solar sail, but now it's got a laser that's zapping it to try and accelerate it. So I think more tests are needed. In many cases, we find that these sorts of technologies, it takes a long time for them to get adopted. I mean, it took ion engines decades, even though they had been developed, even though they were really tested and they were shown that they could work, that no mission controller was really interested in testing out an ion engine on their spacecraft until someone had done like a long-term demonstration. So it's going to be the same way with solar sails. People have to run some prototype tests to show that these things work, and then we'll see them attached. And I can imagine this future where there will be a solar sail attached to every mission, because why not? You can have a small little bag of mylar that's attached to your spacecraft, and if something horrible happens where it doesn't get to its ideal orbit, the solar sail deploys, and maybe it takes you another year, and your spacecraft will get up to its final orbit thanks to the solar sail. So I can't wait to see this be tested out. Oh, there you go. So Raj Luthra is saying that the Falcon Heavy launches on the 24th of June. So we are a week away from the light sail going to orbit. So I can't wait. All right. So Abishkilhari. As most stars we look at are actually a snapshot of them years ago, doesn't the light that originated from these stars several years ago just stop traveling, resulting in us never detecting them? No. Photons moving through space, the light moving from these stars, never stops. It'll travel for billions of light years across the entire universe. As long as it doesn't bonk into anything, it will travel across the entire universe, travel forever. And so when we look out into space, we can see the afterglow of the Big Bang. Now, it happens to be 13.8 billion light years away, or the light has been traveling for 13.8 billion years. The actual space is now like 46 billion light years away. And it shows that light can just go and go and go. As long as nothing bumps into it, it will just keep traveling throughout the entire universe. Jan Korniloff says, but what kind of bit rate could we get from such a small probe light years away? You would need a very, very large antenna to receive the signals. But this is a question that I actually asked to Avi Loeb, one of the project designers of Project Starshot, which is, I mean, sure, we can send these teeny tiny little spacecraft off to another star system, but how can we communicate with them? And his answer was, we can. That if they point back at the Earth and they send a very focused transmission in our direction, and we have a very big receiver to receive their signals, we can receive a very low bandwidth transmission. So we can actually see pictures and videos of Alpha Centauri when a teeny tiny spacecraft zips past, which is really exciting. I can't wait to do that. Now, I did an episode, again, about 6 months ago about this mission called Project Dragonfly, and the gist of that was a much beefier spacecraft, something that was, say, 1,000 kilograms that could make that kind of journey, and it would have a lot more ability to stay at Alpha Centauri, to be able to analyze it, and to be able to transmit home. So the technology is available to us. We just need to go after it and work on it for, I don't know, 50 years to get there. Pizza Cake, what are your opinions on asteroid mining ethics possibilities? The new episode that is actually uploaded, the patrons have already seen it, talks all about planetary protection. So I'm ambivalent. I'm of two minds, right, about asteroid mining. On the one hand, the future of resources for humanity is going to come from asteroids. It's going to come from the solar system. And so I think that it's just a matter of time before we take these asteroids and we dismantle them. I mean, some of them, right, they want to crash into the Earth. So I think there are no ethical problems of dismantling an asteroid that is on its way to crashing into the Earth in some future time, for raw materials. And just one asteroid, there are asteroids out there that are fairly small that would have as much gold or platinum or iridium as all that's ever been mined off of planet Earth in the history of humanity. So there's some ridiculously valuable asteroids out there. And so asteroids, man, I don't really have any problem with asteroids. Grind them up, turn them into our Dyson sphere. When you talked about some of the other worlds, places like Mars, some of the moons of Jupiter and places like that, then they're a little more, I think, sensitive. I mean, potentially they could have life on them, but then also just like the geological history of Mars is laid out in these surfaces on Mars that are billions of years old. It would be sad if we just immediately turned that into we just strip mined Mars to get materials. And of course, right, gravity wells are for suckers. So I don't think we need to go and mine Mars or Venus or any of those worlds. We can find everything we need from asteroids. Mike Doman, any comments on why we still haven't tried out any rotating habitats in orbit? No reason. They are complicated and expensive. I think I did the math one time that if you wanted to build, say, the big rotating space station that's in 2001, you're looking at like 65,000 SpaceX Starship launches to carry the cargo up to do that, or Falcon Heavy launches. Like it'll never happen, right? We will never build something that big from launched here on Earth. The only way we're going to build something like that is through asteroid mining and space-based manufacturing, where you take an asteroid, you dismantle it with robots, the robots build more robots, and then the robots build more robots, and then those robots will build parts of a big rotating space station and then push them off into orbit and then assemble them around the Earth. That's how those are going to come together. And so we have to master space-based resource extraction and manufacturing before we stand any chance of building some of those true solar system spanning structures. So got to wait for that. But Mike Doman, so Mike Doman's noting, so there are some smaller ones. So there's been a couple of interesting proposals. One, there's this space station module called Nautilus X, which is like a small ring that would be attached to the side of the International Space Station, and it would spin. And so the astronauts would do their work floating around inside the space station, and then at the end of their day, they would move to this Nautilus X module, and then they would be spun in this module, and they would get artificial gravity for several hours. That would help with the redistribution of fluids in your body and the lack of gravity that you experience. And I think that's the right medium ground that we need to see, which is someone needs to attach some kind of rotating thing to the space station, spin it up, and find out if spending time in a rotating space station helps. And I mean, they can even be like a single. I've seen some interesting designs. There's like a teeny tiny rotating module that you could fit inside, say, like a Falcon 9 fairing, that that would just kind of rotate around, and you would sit on a bicycle, say an exercise bike, and then you'd be spun around and you would experience gravity while you worked out. And it would just be big enough for you to feel sick, right? You in the beginning, and then you would become accustomed to it over the weeks and months. And it would just provide that just tiny little bit of gravity. And so these are the kinds of ideas that we need to figure out, not the big, gigantic rotating space stations that this is it's way beyond us, right? We need to figure out what is the smallest practical method of providing some kind of artificial gravity to astronauts in space. And that is something that we're going to get to. Yeah, Josh M is saying, yeah, even half of Earth gravity is a start. Yeah, so I mean, we don't know. We still don't know. It could very well be that if you experienced 15% of Earth gravity spinning in this little centrifuge, that's enough to put off a lot of these health effects of being in microgravity. Or it might be that you require Mars level of gravity, or it might be that you need 100% gravity, or maybe you need to spend time in 150% gravity to overdo it. We just don't know, and we need to know. And I think if I was to put a priority, that would be one of them for sure. Is something like the Nautilus X, or one of these tiny little centrifuges that astronauts could spend some time in. I apologize for the people who are listening to this as a podcast where I have these blank spots. I got to remember to like fill the time, because I've had people get back to me and they say, "Oh, I thought the podcast was over," because there's a big long blank spot, but I'm really just thinking. So again, I'll tell you when it's over. It's not over yet. Let's see. Brad McGashett. If dark matter particles really exist, do they think they'd be able to form solid bodies similar to stars and planets and even black holes? So the idea about dark matter is that whatever it is, and obviously astronomers still don't know what it is, it doesn't interact with regular matter in any way, and it doesn't seem to interact with itself in any way. And the idea is that it has a very small cross section. In other words, if you imagine particles of dark matter like little balls, and they would have some size so they could bonk into each other, whatever dark matter is, that size is so small, that cross section is so small that they just pass right through each other. And so if you had two huge clouds of, say, hydrogen gas, and you threw them at each other, they would smash into each other and they would collapse down and you would get stars forming. But if you took two huge clouds of dark matter and threw them against each other, they would just pass through each other. And so, you would need a bigger cross section for them to be able to collapse into stars and planets and things like that. That said, dark matter will absolutely go into black holes, because everything goes into black holes. But it would have to be in the perfect trajectory, right? So with a big cloud of hydrogen, if you put a black hole in the middle of a cloud of hydrogen, then the hydrogen is going to be bonking into each other, and it's going to be slowing down, it's going to be swirling around and going into the black hole, while a cloud of dark matter isn't going to be bonking into each other. So it's just going to spin around the black hole. Some particles will go in, thanks to gravitational like waves and loss and things like that, but the vast majority, because they're not bonking into each other, they're not going to go into the black hole. Walid Damouni, do you think that a moon base is going to happen within the next 50 years? Yeah, I think so. 50 years? Sure. I think we're going to have something like Antarctica on the moon within the next 50 years. There will be a permanent research station on the moon like there is the International Space Station. I mean, when you think about it, right, there have been human beings on board the International Space Station since it was launched. Like 20 years of continuous habitation. There is always astronauts up in space, and we're going to see that again for as long as the International Space Station remains, then the Chinese space station, and eventually there will probably be some moon research base, probably within the next, I wouldn't even wait 50 years, probably the next 20 years, where there will be, and then they will just send new shifts of astronauts back and forth from Earth to the moon to spend more time, I don't know, mining helium-3, but mostly just studying and exploring and doing things like that. I think that your second question, what do we think the moon base will be used for, science or tourism? It'll probably be both, right? Just like the International Space Station is going to be used for tourism soon and has been used already. So you're going to see people being able to go to the moon base and be able to spend time there, and they'll pay through the nose, and that'll help to fund the moon base, but it'll also be primarily there for science. Not a lot of science that you can really do on the moon, but the main thing that you can do is you can learn how to live, right? Like people always ask, like, what is the scientific purpose of space exploration? Well, the purpose of space exploration is to send humans to space and keep them alive. That's it. That's the science, right? And I think that it'll be the same thing with the moon. People will take astronauts to the moon, and the question is, how do we minimize the radiation, and how do we grow our food, and how do we deal with the lower gravity, and how do we get along in a confined space, and what do we do when alien xenomorphs break into our space station and eat up everybody? So that's what we'll want to learn how to do. Shmez, how many people do you think will be living in space by 2100? So in about 80 years from now, I don't think there will be a lot of people living in space. Maybe there will be a few hundred people by the end of the century. Like you're going to have a bigger version of the space station. You're probably going to have, maybe you will have had a base on Mars for a little while. I don't think we're going to see a big civilization on Mars, like big cities. I think it's going to be the same thing. We're going to learn that living on Mars mostly sucks. And so you go to Mars and you're like, woohoo, I did it. Here I am. It's a desert and it's dry and I can't breathe and it's cold and the radiation is nonstop and I miss Earth. And people will come back to Earth. And there will be a scientific outpost on Mars, which is very important. There will be a scientific outpost on the moon. And that's about it. And then there will be bigger and bigger space stations over time until eventually we see big L5 colonies like Gerald O'Neill predicted. And that is when, but that's going to be a while before we see these big, big space station civilizations. But I can imagine 200, 300 years from now, there will be millions of people living in space. Mike Doman, does the recent discovery of heavy metals in the Aitken Basin make moon mining more likely? I don't think so. The discovery that you're talking about is the largest impact crater in the entire solar system is located at the bottom pole of the moon, and astronomers have done some gravitational mapping of the moon, and they've realized that what probably caused this gigantic crater is a huge planetoid that smashed into the surface of the moon and buried itself into the surface. And so there will be metal there, but it's going to be pretty hard to get at still. I mean, you're going to have to dig pretty deep to get at it. And it's down in a gravity well, right? The lunar gravity well, which is still bad, right? Why dig metal out of the lunar gravity well when you can get it from an asteroid? I think it's really important to understand how much gravity costs for you to get your stuff to some other place. Right now, we're looking at, say, 1,000, like back in the space shuttle day, it was like $10,000 a kilogram to get to low Earth orbit. So say you have a kilogram of steel. I don't know what a kilogram of steel costs, a couple of dollars, and then you throw $10,000 on top of that to get it up into space. Maybe we can bring down the cost thanks to the Falcon 9 and the Falcon Heavy to $1,000 a kilogram, right? So your kilogram of steel costs $2 for the steel and $1,000, and maybe the Starship will bring that price down to $200 a kilogram. But still, that's a lot to spend for steel when you could spend all that money to extract it off of an asteroid and it's already out in space. And so the amount you're gonna have to spend to move it off there is much less. Now, the cool thing about the moon is that you could set up a space elevator using technology that we have, using materials that we have today. There's various carbon fiber fabrics and ropes and things like that you could build. You could build a Spectra lunar elevator today, and it would work just fine. It would be a great place to build it. So it could very well be that a lunar elevator is the best place. And maybe that's what they'll do, is they extract the helium-3 from the surface of the moon and burn them in their fusion space drives. But that's a ways away right now. Right now, we struggle to get to space. So, Bionic Bro, do you put your books in any particular order? No, they are in the order of when they were sent to me. So, I have a pile of books. The book publishers send us books all the time and we do a lot of reviews and promotions and interviews and things like that. And so, I have the top 4 things of that shelf filled with books, and then when they fill up, I take them all down to the library and donate them so that people can read them. Let's see. Curious Borg, approximately when will the ISS fall out of the sky? I think right now there are plans to maintain the International Space Station until 2028. So I think we're going to see it still maintained for a while. I doubt that they'll let it deorbit. Like, as long as it's still functioning, I wouldn't be surprised if they'll continue to boost it, because there will be new technologies. There's going to be the Starship, there's going to be the Falcon Heavy, there's going to be a lot of stuff that can help raise the orbit of the International Space Station. As long as it's mechanically sound, as long as there is still value, I think they're going to still operate it. And if parts of it start to really run down, like what happened with the Mir space station, then I think we'll see it finally be deorbited. But it could very well be that that the Americans abandon it, but the Russians keep maintaining the space station, or vice versa, that the Russians decide they're out and the Americans decide that they're going to keep on maintaining it, which is sort of a strange part of the collaboration. Maybe the Russians will sell their part to the Chinese. Who knows what the future holds for all of this. Lawrence Bell, thank you for ignoring Doctor Who for this. Worth it. Waleed Damouni, will you brave to go to the moon if you can? I'll be the first to be second. Yeah, I think that's exactly it. I would love to go to the moon. The moon would be amazing, right? To be in that low gravity, to see the night sky from the surface of the moon, to look back and see the Earth. That would all be tremendous. And if there was a safe way, I'll be third after you. If there was a safe way to go to the moon and come safely home, I would totally do it. Same with Mars. Mars is a big time commitment, right? The moon, you could get up there in a couple of days, spend a week up there, take a couple of days to come home. Mars, you're looking at, with a fission rocket, you're still looking at 3 months to get there, and then 3 months to come back. So, and so many ways to go wrong. Let's see. Zappan, did you read Artemis by Andy Weir? I haven't read Artemis yet, although we did interview Andy on the Weekly Space Hangout, which I think you might have remembered. So I've read his new book, Outland. Oh, sorry, no, that was someone else. But yeah, no, I haven't read anything. I've read The Martian, but I haven't read Artemis yet. One of the cool things that we talked about when we did the interview was how there's so much aluminum oxide on the moon that it actually would be very easy to build structures out of the moon dust. And so you could build, and in fact, there was so much that you would have too much oxygen that you would need to vent or store or lock up as you were building just your structures out of the lunar regolith, which is really cool. So I think that there's some good ideas to live on the moon, but I think you're still, at the end of the day, you're on the moon and it's not the Earth. And again, I think in the beginning, you'd be like, I'm on the moon. This is the best thing ever. And then, I don't know, 6 months later, you're like, oh, I'm on the moon. I can't wait till I can come home. Like The Moon. Was it Moon? Moon, yeah. Check out Moon, the movie. It's so good. And you can just see it's like after a while, you're just like, oh, everything's covered in dust. I can't breathe. There's nothing good to eat. I haven't seen an ocean in a long time, a tree. I just want to come home. There you go. So people are saying it's a good book. Bionic Bro. Which Hollywood director would be the first to film in space, ISS moon? Uh, Tarantino, Cameron. I'm sure James Cameron will be the first one to actually shoot a movie in space. Are you kidding? That is absolutely a thing that he would want to make happen. I'm amazed he hasn't flown to the International Space Station yet. Phoenix Uprising. Do you know if they are planning on bringing along insects and worms to help terraform and irrigate Mars? So the last video that I just did was all about how hardy life forms are. And one amazing experiment that they did on the International Space Station was they took a bunch of mostly plants, so some algae, some lichen, some cyanobacteria, some archaea, and they put them into earth dirt and Martian regolith simulant. They took them to space. They made them eat vacuum of space for years, for like 2 years, and then they brought them back down and they opened them back up. And in one case, they open it up back up to Earth. In the other case, they open it up to Mars, to a simulated pressure and temperature of Mars. And they were just fine. So our creatures here on Earth, we have many life forms that are ready to go to Mars today and would be able to survive on the surface of Mars, which means that it's very likely that we will be able to infect Mars with our own substances. So I think that, and that's what the next episode is all about. It's all about planetary protection, which is like, how do we go to Mars and not infect the place? And it's not just, I mean, obviously we don't want to kill all the local life forms. We also just don't want to find life on Mars and then realize that it was Earth life all along. You know, everywhere you look, you just keep finding Earth bacteria thriving, having a great time. You know, thanks for the new habitat, dummies. So, let's see. Aside from the moon and Mars, what would be the best target to send humans to scientifically? Scientifically, there is no reason to send human beings anywhere, right? Robots can do all the science that we could possibly want. The reason that we send humans is to send humans. That's it. So scientifically, the question is, what is the best place to scientifically learn how to send humans to space? Is space. If you can master just space, just regular old space itself, then you can go to the moon and you can go to Mars, because with space, you've got to do everything. You've got to build your habitat. You've got to protect from the radiation. You've got to recycle your atmosphere and your water. You've got to grow your food. You've got to be able to communicate, and you've got to be able to not get space madness. So I think that is and again, that's my priority. I know a lot of people have different priorities, and Elon Musk obviously will deeply disagree with me, and Dr. Robert Zubrin will deeply disagree with me, and that's fine. I'm inspired by their opinions and what they've been able to accomplish, but I personally am 100% a Gerard O'Neill fan with orbiting colonies with the L4 and L5 points. But that's me. Again, you know, we don't know. Nobody knows. I mean, a lot of this is just idle speculation. Let's find out. Let's start trying some of these things. And that's my only concern, is that it's all goal-based. We're going to the moon. No, we're going to Mars. Like, maybe, sure, I don't know. But let's just get better at sending humans to space and living for longer periods of time and realizing what breaks and then fixing them, so that we can last longer. We talked about this last week, right? That the Biosphere 2 was this amazing experiment about trying to create a truly closed environment. And it turned out that the concrete was pushing out carbon dioxide as it was curing. And so they weren't getting a properly sealed environment because it was having carbon dioxide ejected into it. But for a lot of the time, they were actually doing really well. And they were growing all their own food, and they were taking care of all their own animals and all of that. And that's the kind of knowledge, the kinds of skills that we're going to need to be able to live in space. And once we master that and we minimize that and figure out what is the true specific things that we need, we're always going to struggle to live in space. It is always going to be too difficult for us. Jack J, what is the slowest moving entity known in space? We are moving through our solar system is moving through the galaxy is moving through. What is the closest to absolute zero? The closest thing to absolute zero is your chair compared to you. Maybe your house compared to you. So everything's relative, right? And yeah, as you move away from the Earth is moving 30 kilometers per second around the sun. The sun is moving, I forget the number, like some 250 kilometers per second around the Milky Way, and the Milky Way is moving. And so at every scale, things are moving faster and faster. And there is no absolute measurement for the universe. That's what relativity is all about, that everything is relative no matter where you are. You can measure your velocity compared to something else. And because there is no absolute measurement, everything is relative. When two things are moving towards or away from each other at tremendous speeds, time is the thing that has to pay the price. Time has to change so that you don't break the speed of light as you're watching each other, which is an amazing idea. And that Einstein thought of that time bends so that the speed of light must always remain the speed of light. It's Destonks 333. Does the moon have any natural satellites? No. The moon does not have any natural satellites. And in fact, the moon is really bad at having things orbit around it. It has a very bumpy gravity map. And so even our spacecraft aren't able to orbit the moon for very long without a lot of changes, a lot of fixes to their orbits. They tend to crash into the moon after a relatively quick amount of time. So nope, the moon is just too small. And so if it tried to have a moon, the Earth would steal it or smash it, use it to smash it into the moon. The moon is not allowed to have a moon. It's too small. In theory, you could have a moon. So Neptune could have a moon, a very large moon that's far away from Neptune. And then that moon could have its own moon. That could be stable. And so there's a few situations where this would be possible. But in general, we don't know of any moons with moons here in the solar system. There are asteroids with moons, but they're not really moons with moons. So, Walid Damouni, if going to space is the driving issue, shouldn't we build more permanent launching infrastructure like launch loops? We already spend billions launching stuff. I mean, I mentioned this earlier on, right? That we are going through this phase where launching things is becoming a lot cheaper. A launch loop, right? Some kind of magnetic maglev system for launching things out into space would be cool. There's a lot of engineering challenges to be able to do it, and there's something just simple about a two-stage rocket that uses all its fuel and doesn't burn up. That is a completely reusable rocket where it just takes off, detaches, goes to space, both parts land. You fill them up with fuel again, and they get used again. That is very simple, very inexpensive, allows you to iterate, right? Why do we fly in airplanes when you could theoretically have a maglev train cross the Earth, right? Just an airplane is a single discrete thing. They can take off from anywhere. They can land anywhere. They make a lot of sense. So a launch loop would be the kind of thing that a very, very far future civilization might create if they're absolutely certain that they're going to want to launch stuff into a very specific orbit for a long time, and they really want those cost savings. But we still have there is nothing that makes space exploration a profitable venture. And so there's no reason to build something as enormous as something like a launch loop. Now, maybe in the next century we will. But for now, the same thing with space elevators. There's no business model that works yet until we learn how to mine the asteroids. Luis Tapia, hey man, do you think that we will take serious viruses such as Ebola, rabies, etc. to other planets such as Mars, and how likely is it can be catastrophic to the exploration of the planet? So we're going to take our viruses and bacteria to Mars with us. When you look at some of the stuff like the E. coli, is it salmonella? There's a bunch of like bacteria that we have that are really tough. Staph, strep, they're tough. And so I mentioned this before that, in fact, this is, the new episode dropping tomorrow is all about this. So stay tuned. Empirical. Are there any missions to study the moon's lava tubes? How could such a mission work? This is like, tonight is like the, hey, Fraser, tell us about an episode that you did in the past. So about a year ago, maybe someone will put a link, I did an episode all about exploring lava tubes. Why lava tubes make a ton of sense on the moon and on Mars, and the missions that have been proposed. There was a new mission that just came out from NASA's Advanced Concepts Lab about a potential mission to explore the vicinity around a lava tube. And I had mentioned it in the episode, but it was still sort of more up in the air. And now they've got some phase 1 funding from NASA. I forget the exact name of it, but I think it's Cornell's robotics lab is going to be doing the work, and so the plan is they'll launch this rover that'll land beside a lava tube and then noodle around the top of the lava tube and map it out in great detail that then humans could come back to at some point and be able to land. Lava tubes are great. Lava tubes are like the only mildly hospitable places you could go to on the moon and Mars, where you're blocked from the radiation, the temperature's a little warmer, and you could have access to ancient geological formations. You could study the surface of the moon or Mars. They're great places to go. Free Time is saying it's a clip show. Yeah, this is a clip show. I should totally edit in all of these past videos. There you go. Paranor just posted it. Living underground on other worlds, exploring lava tubes. So there you go. I have made a video on every subject you could possibly ask. Greg Pine, we don't employ many monkeys. What will super intelligent AI do with us? Good question. It all comes down to the control question, right? Can we give artificial superintelligence some kind of goal that doesn't end up with us being unnecessary? And if we can, then we get to come along for the ride, and AI becomes the strongest, most powerful tool humanity has ever invented, the most powerful tool in the universe. And if we mess it up, then we are no longer relevant. And I hope the AI treats us like we treat monkeys, which is like mostly badly, but kind of lets us live. And the AI could do a lot worse than that. Curious Boring, any excuse to make Fraser say lava tubes in his special Canadian way. Lava, llama, pasta. There you go. I'm sure my wife's ears are ringing right now. BM Wolgast, if you were to take an AM/FM radio to the moon, would you be able to hear any signals coming from the terrestrial radio station on Earth? What would the AM/FM dial sound like? So a standard AM/FM radio, no. It's too far. The signal would be attenuated, and you wouldn't be able to hear any of the signals from Earth. Now, if you took a 90-meter dish and you pointed at Earth, then absolutely you could tune into the radio stations. So it's really just what is the size of your radio receiver that you're willing to take along. People always say, like, how can they hear from the Voyager spacecraft when I can't receive a phone call? Well, if you're willing to drag around a 70-meter dish attached to your cell phone, you could get great cell service almost anywhere you want it to go. So a really cool fact is that the upcoming square kilometer array, which is going to be this gigantic radio telescope that's going to be built in South Africa and Australia, will have the ability to detect Earth, the radio traffic of, say, airports to a distance of 50 light years. So when the square kilometer array comes online, if there are any alien airports within 50 light years, we'll be able to start detecting them, which is just amazing. Dill Pill, what are your views on AI ethics? I did a whole episode on existential threats about 6 months ago, and I think you'll get the gist. of my thoughts on AI. I've also answered in a couple of question shows. My opinion is AI is one of the most dangerous and powerful tools that we could possibly create, and there are risks, and we should be well aware of them and be careful as we start to create tools that are that powerful. So they are worthy of study, and there's this idea of called the control problem, that at the end of the day, you need to be able to essentially control your AI, and if you can't figure that out, then you got a problem. And if you can, which is actually a really hard problem to solve, then you may stand a chance. So I definitely, there's a series of existential threats that I am mildly unnerved about. And so we did a whole episode. There we go. Thanks, Paranor. This is great. I love this. So it's Open Space 29 was existential risks with Phil Torres, who spends his time thinking about existential risks. All right, we've reached the end of our 1 hour. So thank you so much for everyone who has watched. I really appreciate it. As always, next week, so new episode dropping tomorrow, all about planetary protection and how will SpaceX be able to colonize Mars and not fill it with our filthy bacteria. Another question show coming up on Thursday, and then one more open space next week, and then we will go on our summer hiatus for our live shows. So there won't be a live show until September, but there will be lots of other question shows and guide to space videos, and someone asked about the star parties. So what's happened is Oceanside Photo and Telescope has been dismantling and upgrading all of their telescopes, so they're down right now. They will be back within probably another month from now, and so as we go into our summer hiatus, I'm going to have a lot of time to spend with these different telescopes, and my plan is to spend a lot of time playing around with live telescopes and broadcasting it. So we will you'll see lots of announcements about it, and I hope you'll join me because it's a lot of fun. All right, thanks everyone, and we'll see you all next week.